we have to prove root 3 is an irrational number. First we assume that root 3 is an rational number, then we contradict it and we will prove that root 3 is an irrational number. So first assume that root 3 is a rational number. Root 3 is a rational number. First you assume. Next is we will write root 3 as p by q, because in any rational number we can represent it by p by q form, where q is not equal to 0. This is important. And second thing is p and q are integers and co-prime. That you have to always write. P and q are integers and co-prime. Co-prime means p and q has only one common factor, that is 1. Next, squaring both the sides, we will get root 3 square is equal to p by q whole square, or 3 is equal to p square by q square. So p square is equal to 3q square. Now if we can write this actually as p square is equal to 3 into q square, that means 3 is a factor of p square. So 3 is also a factor of p. This is the first thing we have to write. And the second thing, we have to show that also 3 is a factor of q. As this is the common factor, 3 is a common factor of p and q, so they are not co-primes and it contradicts our assumption. So root 3 is an irrational number. That we have to show. Now, as 5 is a factor of p, we can write p as not 5, as 3 is a factor of p. This is not 5, this is the factor is 3 is a factor. As 3 is a factor of p, we can write p is equal to 3k. So now squaring both the sides, we will get in this equation. In equation 1 we will put it in place of p, we can write it as 3k whole square. In p square, that is 3k whole square. We will get 9k square will be equal to 3q square, or q square is equal to 9k square by 3, or 3 into k square, that is q square is equal to 3 into k square. So 3 is a factor of q also. Now we found that 3 is a factor of p as well as 3 is a factor of q. Hence p and q are not co-primes as our assumption. We assumed that p and q are co-primes, but they are actually not. Hence p and q are not co-prime numbers. Our assumption is wrong and root 3 is an irrational number.